Alright guys, so some of you guys asked me for a video to do a review of for your quiz tomorrow, and so that's what we're going to do. Let me just adjust this. I think we're good. Alright, let's go. So basically what you're going to do is I'm going to put up some problems on the board, and you can pause the video and then do the problem, and then I will do the answer on the board after. So let me list your topics that you're going to be on your quiz tomorrow, and you can write this down. It'll be on midsegments. There will be perpendicular bisectors. There will be angle bisectors. And, of course, circumcenter, which is connected to your perpendicular bisector. See? And your angle bisector will be with incenter. If you're wondering why they're connected, perpendicular bisectors are the ones that make your circumcenter, and angle bisectors are the ones that make your incenter. Okay? So anytime you need to pause, just, pause it and then you can keep going. And if you need to hear it again, you can do that too. So I'm going to erase this. Now let's go over midsegments. Okay. Now once again, midsegments are made of the midpoints of each side connected, right? So I will make one for you. Okay, remember we do midpoint to midpoint to midpoint and then connect them. I would use a ruler, but this board is kind of hanging off my wall a little bit. The ruler is sort of helping it stay up, so if I take it off, it's going to fall over. Okay, alright. So if I give you, I want to find the perimeter of this triangle. Okay? And I tell you that the midsegment is 49 right there. This midsegment is 42. And this midsegment is 6x minus 1. And this length is 13x minus 10. Now, you'll likely want to go back into your notes to figure out what are the properties of midsegments. Okay? So do that. Pause this. Go ahead. Do the problem. But I will keep going. So we want to find the perimeter of the triangle, this big triangle. Okay? And that means that we need to do some calculations. I'll add on to this. So as the midsegment, multiply it by 2 and you get the disconnected side. 49 times 2 gives me a length of 98 down here. I hope you guys can see the pink. I think it's okay. All right. 42, the midsegment times 2 gives you the disconnected length, and so that's going to be a length of 84. Okay? Now, the last one, we're going to have to do some calculations here. Now, 2 times the midsegment is equal to the length of the side. So we're going to do the calculation, and it's going to look like this. You have to solve for x first. But let's set it up. 2 times the midsegment is equal to the disconnected side. Okay? So, if you want to pause it and do that calculation, that's fine. 12x minus 2 equals 13x minus 10. Don't forget to distribute to each of the terms inside the parentheses. Okay? So, now we got to move everything to each side, so I'm going to subtract 12x minus 12x plus 10 plus 10. This goes away. This becomes 8 equals x. I'm not done yet, because I want to find the length of this side. So what I have to do is I have to plug in my x as 8, and then I'll find that side. And I'll get 13 times 8 minus 10. Okay? And that gives me 94. This is 94 up here. And the perimeter is adding each of the sides together. So I will do 84 plus 98 plus 94, and that gives me a total of 276, and there's your answer. Okay, if you need to watch it again, you can do it again. Of course, I recommend that you go over your notes, go over your homework that I've given you, all of that good stuff, okay? Here it is once more, so if you need to pause it, then you can do that. But let's move on to perpendicular bisectors. Okay. Perpendicular bisector has a theorem and a converse. Of course, the midsegment has a theorem as well that you should be going over. It's the one that tells you that it's half of the disconnected side and that they're parallel. Oh, actually, you know what? Let's do another midsegment first. Let's work with the parallel one. So I'll give you this one. We're going to be working with the angles. Point to midpoint. Okay. And the midpoint is parallel. Okay. So that's not going to be given to you. It will just tell you that this side is the midsegment. Okay. And here is angle 1. Here is angle 2, angle 3, angle 4, and angle 5. And I'm only going to give you the following angles: 59 degrees, and I think this is 127 degrees. Okay? So if you want to pause it right here and see if you can figure out all the measures of the angles. You can go ahead and do that. But otherwise, let us move on. So we need, because I've told you that they're parallel, you should know that you should be remembering all your parallel line theorems. That'll include alternate interior angles, and alternate exterior angles, corresponding angles, and same side consecutive angles will be supplementary. Okay? Between these two, we don't really have an alternate interior angle. We don't have any alternate exterior angles. You know, we've got corresponding and same side interior. Remember, these two are the ones that are parallel. These are the separate transversals. Okay? When you're doing calculations, you only worry about one transversal at a time, and then we're going to work on that one. Okay? So let's work on this bottom one first. 59 right here. This is corresponding with angle 4, and so this one is also going to be 59 degrees. Okay? It is it's same side interior with angle 5. So if I do 180 minus 59, I will get angle 5. And that'll give me 121 degrees. I'll fill that in right there. Remember, you want to fill out your diagram as you go. Okay, otherwise it's going to get really confusing. If I didn't plug this in here, you're going to have a hard time figuring out how to find angle 3. Alright, well, we figured out what we can do right here. Okay, so let's go to our other transversal. We're going to work up top now. So here we have angle 2 is supplementary with 121 and corresponding with angle 1. We could figure out angle 1 first or angle 2 first. I think a lot of you guys would be more comfortable seeing the angle 2 first. So if I do angle 2 plus 127 equals 180, that gives me angle 2 is 53 degrees. So I'm going to put that right here. Okay. Angle 2 and angle 1 are corresponding angles, so I'm going to put 53 degrees right here. I'll fill that in up there. Okay. And now I've got a triangle right here. Of course, the triangle angle sum theorem says that the three angles of a triangle should add up to 180. And if I do that, 53 plus 59 plus angle 3 is 180. That gives me angle 3 to be 68 degrees. And now I've completed my problem. Okay? Here's the problem right there. If you want to pause it and check your answers against it, go ahead. But we're going to move on now to angle bisectors. Okay. Oh, no, perpendicular bisectors. I'm sorry, we're going to perpendicular bisectors. I like these colors. Okay, so we know perpendicular bisectors. So we start with a segment. And if I have a perpendicular, this is my midpoint. If I have a perpendicular line from there, I know that any point on here will be equidistant to the sides of the segment. So I'm just going to start up here, and I'll connect it. I'll connect this one, okay? The theorem says if this, then, then this, okay? So for you to have a little bit of help, if I just gave you, so I give you 7x plus 24 over here, and 13x minus 48 over here. Well, I see that it's a perpendicular bisector, so I know that these sides are going to be equal. I'll set them equal to each other. 7x plus 24 equals 13x minus 48. Okay, minus 7x plus 48. And doing all the calculations, I get x equals 12. Okay, I'm just looking for x right now, but if I told you that you wanted to find a side, one of these sides, you're going to have to plug it in. Okay, so make sure you're always paying attention to what the directions tell you that you're looking for. Don't just stop at finding x, because that might not be the final answer. Okay, so this is the perpendicular bisector. That was perpendicular bisector, so now we're going to move on to the perpendicular bisector converse. And that means that we're going to start with our sides being equidistant. And because of that, we know, so I'm going to start with an isosceles triangle. Okay? And when we start with an isosceles triangle, then we can say that the top down to the bottom is a perpendicular bisector. Okay? So if I ever give you an isosceles triangle, you know what to do. So if I give you this information, at the bottom, 17x minus 3 and 9x plus 13, you know that this is congruent to this one, so their measurements are equal, and we know how to put that into a formula now. 17x minus 3 is equal to 9x plus 13. Okay? And then we go, and we get x equals 2. Okay. Remember, guys, if you need to pause it, I might be going a little bit quickly, so just pause it before I can start talking about the answer. So that's perpendicular bisector and its converse problems. Okay, so let's move on to the angle bisectors. If you want to pause it and review your angle bisector notes right now, go ahead and do that. Angle bisector looks really different than perpendicular bisector. The problems look really different, and on the quiz I'm going to tell you what you're working with at each point, okay? But we know that if I have an angle, okay, and I bisect it, okay, of course the bisector means that I did that with it, then any point on that angle bisector will be equidistant to the rays of that original angle. So this congruency right here is the conclusion of that theorem. Okay. So what if I gave you that this is 4x plus 30? Well, let's erase this. This is what it'll look like on the quiz. It'll look like this. And you can see that this is two triangles. It's not one triangle because this side is not one line, right? So you can say, okay, well, this is angle bisector. I know it looks a little bit weird. So this one's going to be 4x plus 30, and this one is going to be 9x minus 5. You can pause right here if you want to solve for x. Okay, so we know, because this is an angle bisector, I know that because of my congruency lines and all of this, then I can say this one is congruent to this one. I set up my formula. doing all of the math, okay, I'm going to move to my smaller coefficient. 35 equals 5, nope, what is that, 5x, and x equals 7. Okay, that's the answer for that one. Okay, so let's try a converse of the angle bisector theorem. Okay. A converse says if I start with points equidistant on a line that cuts an angle, then it is an angle bisector. Okay. So it'll look something like this. Actually, this. If I give you that this angle measurement is 5x plus 11, oh no, minus 11, sorry, and this one is 8x minus 41, go ahead and do this problem. You can pause it. Okay. However, I'll explain it. So, oh, sorry. This is congruent to this. This is the requirement of the converse. These sides need to be congruent. So if these sides are congruent, then these two are, this line is an angle bisector, which means that these two angles are congruent. 5x minus 11 equals 8x minus 41. And doing all the work, I get x equals 10 degrees. Or not degrees, just 10. Okay? So if I plug it in to this one, I'll find out what this one is. If I plug it into this, well, I don't need to plug it into this one. These two are equal. Right? Okay, so that's angle bisectors. Let's move on to circumcenter. And I pointed out earlier that circumcenter is connected to the perpendicular bisector because the perpendicular bisectors all intersect at this one point called the circumcenter. Okay, so let's do that. If I have a triangle, well, I'll just draw out what it should look like, okay? So here's my perpendicular bisector. Here's another perpendicular bisector, and here's my last perpendicular bisector. Okay, this is my hypothesis. If I have this, if I have a circumcenter, then that circumcenter to the vertices are all congruent. So I can make a congruency symbol for that one. That's just a reminder for what you should be filling out the diagram to look like. And I'll remind you again that you will lose points if you don't fill out your diagrams all the time. So don't forget to do that. Let's do a problem on circumcenter now. Let me draw one for you. And when I'm done drawing it, you can pause it. Also, wait for me to tell you what to look for. Okay, so... Well, I'm just going to tell you. The circumcenter point is W. That's in your instructions, okay? So now I'm going to give you the rest of the information. This is 24. You guys see that? 24? This whole thing is 32. This one is 19. And let me see. This VS is 21. Oh, I have to finish the diagram. Okay, so let me tell you what to find. We're finding RS, we're finding WS, TW, TQ, QV, TW, and WV. Okay, so if you want to pause right now and do the problem, okay, I'm going to do the problem. So the first thing that you have to do before you start any problem is fill out your diagram. I was told that the circumcenter is W, which means that I will get a lot of things out of that. It means that it is a perpendicular bisector right here, and right here, okay, to the sides. These ones go to the vertices. That's not a side, okay? This is the side, this is the side, and this is the side, okay? Now, I also know from the circumcenter definition that the circumcenter to all my vertices are also congruent. Okay, now I filled out my diagram. I'm going to get those points, okay? And now I'm going to start filling in what I know. So, let's, oh, I can't see the other color. Oh, here's the other color. Let's fill out what we know. If this is 19, then this must be 19. If this is 21, then this must be 21. 32 divided in 2, here's 16 and 16. Okay, 24 is right there, it's also right there, and it's also right there. So let's see if we figured most of our stuff out. Okay, if you can get all of this, that's like 8 points out of 10, you know? So, let's see, RS. Do we have RS yet? Where's R? R to S is 19 plus 19, that gives me 38. Let's see, WS, well, we figured out that to be 24. TW, let's see, TW, we don't know that one yet. Oh, I marked it twice. Let me just cross that one off. We don't know that one yet. Let's move on. TQ. TQ is 16, and we figured that one out. And QV. Q to V, we got 21 out of that one. WV, we don't know that one yet. Okay? TW, let's see what we got. TW, we have this right here. It's either this, we got right triangle right here, right triangle right here. You can use either one. They're actually exactly the same. Let's use this one because that's where my perpendicular side is. So I got TW, I have the hypotenuse and a leg. Of course, when we're looking for the third side of a right triangle, we will use the Pythagorean theorem. 16 squared plus TW squared equals 24 squared. Hypotenuse is across from my right angle, as you can see. So, if I do all my work, I get TW is 17.9. Okay. Now we're looking for VW. VW is right here. Okay. And another right triangle with two sides. So let's see. VW is a leg. Here's my writing. We have 21 as in the leg, and the hypotenuse is 24. If I do all my work, I get VW is 11.6. Okay. And of course, the last one we'll be working with is Incenter. Actually, I hope you guys can see that. All right. Let us do Incenter. Incenter is the last one I taught you. You should have your notes on it. If not, Incenter is made up of your angle bisectors. So I got this one, and that one. They sort of meet like right there. I know it's kind of crappy, but what are you gonna do? Okay, so I know it's made up of my angle bisectors. So both sides, this one can go to this one, this one, this one, this one, and this one. Okay. Now, coming out, if I have my incenter, then I get sides from the point to the sides are going to be congruent, equidistant. This is congruent to this, is congruent to this, okay? Actually, I'll make them circles because they're on the inside, okay? Another thing that you have to remember about your incenter is that it makes the sides that are cut off by these sides, like this, congruent. So this one and this one, this one and this one. 1, 2, 3, 1, 2, 3. Okay? So you gotta memorize this chart. You gotta fill it out on the quiz for points. Okay? So you can take a picture if you need to. I'm gonna give you a problem. Pretty good incenter. Okay, this is J. This is M. This is K up here. This is K up here. This is N. This is L. This is O. Okay, I'm going to give you 24, 30, 35 degrees. Let's see. I think that should be. Let me just make sure. Oh, okay. This one. Wait. This is P in the middle right here. I give you 13 right there. And this is 32 degrees. That little one right there. I think that's it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. Okay. So we're good. So these are the things I want you to find. I want you to find the measure of angle MJP, measure of angle NKP, measure of angle KLJ, and measure of angle JKL. I want you to find side NP, side KM, side KP, and side PL. So you can pause it and do this right now if you need to. Well, do it. Pause it. But I am going to do the problem. Okay. So I'm going to fill out my diagram first. I'm going to use different colors so you can see what I filled out. And I'm going to have to fill everything out. So all the sides right here, what's this one? Those are all congruent. This side to this side, this side to this side. 1, 2, 3, 1, 2, 3. It also makes all of my little angles congruent. Okay, now that I have that, I can start filling things out. This is 30, then this is 30. This is 35, this is 35 degrees. This is 32, this is 32 degrees. Here's a 24 side. Here's a 30. Oh, no. Nope. That's wrong. I was wrong. I was doing circumcenter. 24 goes up here. 24 right there. And we don't have this side right now. This is 13, so this will be 13, and this will also be 13. Okay. Let's see. I think we're okay for now. Alright, let's see. Measure of angle MJP. MJP is going to be 35 degrees. We figured that out. Let's say, remember, the middle letter of your angle is the vertex of that angle. So I start K, and then we go to L, or no, K, yeah, K, L, J, that is this whole thing right here. I want to know the total. And 32 plus 32 is actually, KLJ is 64. That one's 64. Where's NKP? NKP? Do we know this one yet? Do I have anything for that? Don't have anything for that yet. We'll get to it. Did I give you anything? Yes. Okay. In order to find NKP, I have this angle right here, that's 64. This angle right here, 35 plus 35 is 70. And so I can find the whole thing up here by doing the triangle angle sum theorem. Okay, so 70 plus 64 plus that angle, let's call it x, equals 180. Okay, and that will give me, let's see, 110 minus 64, 46. Okay, so the whole thing up here is 46 degrees. When I cut it into two pieces, I get 23 and 23. And NKP. NKP is going to be 23 degrees. Okay, that took me a little bit of time to figure out too. But I saw, okay, well I don't have a way in this triangle or in this triangle, but I do have the big triangle to work with. Okay, okay, let's see, JKL. JKL. Well, we already know that one. We figured that one out. That's 46 degrees. Let's see, where's NP? We know NP is 13. KM, we found that out to be 30. KP, where's KP? KP. Do we have that one yet? No, we don't have this one, but we do have a right triangle with two of the sides. So, okay. So that would give me 30 squared plus 13 squared equals KP squared. And if I did the math on that one, I get 32.7. And I want to find PL now, right here. And that also gives me two sides, right here, 13 and 30, of a right triangle. If I do the math, so that one, PL will be 13 squared plus 30 squared is PL squared. So PL is going to be 27.3. Okay? And that is the full problem. Okay? So once again, you guys got to memorize these charts. Okay, fill in your diagrams. Even if you don't get the Pythagorean theorem ones, or if you didn't get these two, it's okay. Fill out what you can based on memorizing the chart and filling things out without even paying attention to what you're looking for. Okay, so then you'll fill it out and then you'll start to work from there. Okay, I'll leave you guys with a math joke, bad math joke. What do you call two L's in a row? Parallel! Ha 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 ha! Okay, I hope you guys enjoy your snow day. Bye!